Hi guys, this is a video on applications of parabolas. So quadratic equations and their graphs can be used to solve a wide range of practical problems. We model real life problems using parabolas, so things like projectiles like rockets and balls being thrown in the air follow a parabolic path. So with all these applications, you're going to need to do the problems themselves aren't that difficult. It's in interpreting the information you've got. So you're going to need to be able to define variables. So what's x and what's y, form an equation and solve it. Deciding on a suitable range of values. So what things can x be and what it can't be within the context of the question. Sketching the graph to show the features, and talking about the turning points, which are all stuff we've done, but getting them from worded questions can be a bit tricky. Okay, so a typical example here, a piece of wire measuring 100 centimeters in length. So think about a meter long piece of wire. It's bent into the shape of a rectangle. Let x be the width of the rectangle. Use a perimeter to write an expression for the length of the rectangle in terms of x. So as with all these, every single worded question, every application question, whether it's parabolas or not, I always say the same thing: draw a diagram, okay, and use a ruler if you can. I've got these special inbuilt shapes, okay, so use the diagram and label on what you know or what you're trying to find out. Okay, so I've got my piece of wire bent into a rectangle, and I'm going to write on what I can. So it tells us that the piece of wire is 100 centimeters. So I know that all these straight edges will add up to 100, which means the perimeter is equal to 100. Okay, 100 centimeters. That's important because I know an expression for a perimeter. 2 times the length plus 2 times the width is going to be the perimeter. Okay, so that's an important thing later in the question. Okay, so let's label the bits of information. Okay, so I've already used this bit here. All right, that's my perimeter. Okay, the second bit of information that's useful is x. Okay, that's the width. Okay, so I'm going to call the width this bit here. So x is here, x is also here. Okay, so we've labelled our sides width x, and we're actually not given any more information than that. So what you have to do is let's look at a couple of things. Because this is a rectangle, we know that the two horizontal lines are the same and the two vertical lines are the same. So there's a couple of ways to do this. This is the way I'm going to do it. We're going to say this line plus this line, because these are equal to the other two, that has to be equal to 50 because the perimeter is 100. So it's got to be half of that. So what you can say is that the top line there is going to be 50 minus x. Okay, and obviously the bottom one will be 50 minus x as well. Okay, because if you add x to that, you're going to get 50. Okay, so write an equation for the area of the rectangle, a centimeters squared in terms of x. Now, since we've got our length and width, okay, so we can write an expression for area. Area of a rectangle, we know area is equal to length times width. Okay, so in this case, area, the length, this is the length here, and this is the width here. We simply substitute our values, in, and we get, so let's put the x out first. The width times the length is that. Okay, so that's an equation for area. We should actually put A equals. Okay, so decide on suitable values of x. All right, so this is where you have to sort of think a bit. What can values of x be? Now, x can't be negative. Can x be 0? It probably can't be 0. If you think about it, if you have this dimension, x 0, that will have no length, and the other thing will be 50, which will be a straight line. So it has to be greater than 0. So x, let's write this x, I'll do it properly. X has to be greater than 0 Okay, it can't equal 0, otherwise it's not a rectangle. And it can't be, it has to be less than 50. Okay, so once this becomes more than 50, this length up the top. So once the width is more than 50, then this 50 minus 50 is going to be 0. So this top line would be 0. Okay, so x has to be greater than 0. X has to be also less than 50. Okay, so they're the suitable values for x. We can't have any, can't be negative. Not in this case, in real life. This is a real life scenario, so it can't be negative. Negative values, negative distances don't really make sense. Okay, so sketch the graph of a versus x for all suitable values of x. Okay, so let's have a look at this. This is where our skills come in. All right, so sketch the a suitable values for x. All right, let's find out the x-intercepts. Okay, so we've got a factorized equation here. So we're going to define our variables. We're going to have a versus x. Now, let's see if we can do this. All right. Okay, so in this case, I don't need to draw the negative parts of the line, or the axes, because x can't be negative and area can't be negative either. Okay, so let's look at our x-intercepts. We've got our equation, a equals x, in brackets, 50 minus x. Okay, so to find my x-intercepts, I'll make this equal to 0. So if that's equal to 0, we've already factorized, this is in factor form, so either this is going to equal to 0, so x is going to be equal to 0, or this is going to be equal to 0. 50 minus x equals 0. So we solve that, take away 50 from both sides, and what do we get? We get negative x is equal to negative 50, and we divide both sides by negative 1. Okay, so we get x equals 50. Alright, so I've got my two x-intercepts here, like that, and I can mark them on my graph. Okay, so obviously when x is 0, my area is going to be 0, which makes sense, okay, because I've got a straight line. When x is 50, area is also 0, okay, so going over here to x equals 50 is my other x-intercept. Alright, now, so there's a few other things. We can't tell what it's going to be like. You know, we need to know the turning point. Okay, so let's work out the turning point. The axis of symmetry will give us our x value, and what you might be able to see is because they're symmetrical, the turning point will occur at 25 when x equals 25. So let's substitute in x equals 25. Okay, if those numbers were a bit harder, you could take an average, you could get that. But let's do this this way. So area equals 25 in brackets 50 minus 25. Okay, that'll give us the y value, or in this case it's the a value. Okay, so 50 take away 25 is 25. So 25 times 25 is 625. Alright, so often in these real life examples you get larger numbers. Okay, so this is going to go up to 625, and that's where my turning point is. And you will notice that this one is actually a inverted, okay, parabola. Okay, it doesn't actually go below this x-axis, because remember we said that our values of x greater than 50 don't mean anything. Okay, so turning point is equal to 25, 625. Okay, now, so use the graph to determine the maximum area that can be formed. Okay, so our turning point is at 625. So the greatest area is going to be 625 meters squared. Okay, that's the most area we can get out of these dimensions. What will the dimensions of the rectangle to be achieved to be its maximum area? Okay, so let's, if a equals 625, let's sub in to a equals 50, was it 50 minus, no, sorry, it was x, 50 minus x. Okay, so we're going to make this equal to 625. Okay, so let's solve this. Let's work through this. A is this. Let's work this out. We'll expand it. That's 50 times x minus x squared now equals 625. Okay, so we need to, actually we don't need to do this. Scratch this, you can actually see what the x value is. So let's have a look. You can actually work this out, but it will give you, obviously a maximum area is 625. We know that at 625, x must be 25. So, sorry, get rid of all this. Apologise for that. That's actually not, well, it will work, but we already know we're actually just working backwards to get the same answer. So, x must be equal to 25. Okay, so our length, remember, was 50 minus x. Alright, so if x is 25, it must be 50 minus 25, so length must be 25, sorry, 25. Okay, so dimensions of this rectangle, it's actually going to be a square, which makes sense. Okay, 25 by 25 square for the maximum area. Okay, that'll do for applications. Good luck.